Hi everyone. Welcome to this session about using OpenRewrite and JDT for transforming large applications. There's a word missing from there actually, it's the word Java. So we will be talking a lot about Java. And in case you're wondering if this presentation is going to be terribly relevant for you, we will be talking about large applications, but that's going to be all the way at the end. So my name is Ben Wilson. I am a product manager at the company Vaadin, and I'm responsible for our modernization products. So I do not work for the JDT project, and I don't work for OpenRewrite either, but I'm here today more as a user of the technology, and I'll make clear exactly how as I introduce the company I work for. So who is Vaadin? I made these slides myself, so I did not have any help from marketing to make this, so bear that in mind. A bit of background about the company that I work for, Vaadin, because it's key to understanding what I'm presenting today. So Vaadin is a company, and it's been around since the year 2000. It's best known for its server-side Java frameworks for creating interactive web applications. As I like to say, if you have Java skills and if you have some basic web skills, you can be very productive creating modern web applications that are secure, responsive, and accessible. So today there are hospitals that are running their entire business and operations on applications that they built with Vaadin. There are universities running their entire campus on applications that they built with Vaadin, and there are governments that are running their entire administration on applications they built with Vaadin. One of the reasons why these organizations made the choice for Vaadin to create their mission-critical applications is, well, the architectural simplicity of the way that Vaadin works, which relies on server-side execution, and of course, the fact that there's Java. So Vaadin applications have a lot of Java, and they can be very large. Vaadin also has a new thing called HILA, which fits the reactive programming model and makes it easier to build React applications that run with server-side Java services on Spring. But it's from Vaadin Flow that we get to the topic of JDT and OpenRewrite, and also how I got the input for this presentation today. Vaadin introduced the server-side framework 6, built on top of GWT in 2008. Flow was a complete rewrite of the framework technology based on emerging web standards, and it was released in 2018. So Vaadin 6, Vaadin 7, Vaadin 8, and then Vaadin Flow brand new in 2018. Companies that created Vaadin applications before 2018 were running on previous generation of Vaadin, and they're effectively modernizing their applications at this point by migrating from GWT to the Web Component Standard, and also migrating from the Java APIs of the Vaadin framework to the Java APIs of Vaadin Flow. So this is where I and my team come in. So to help companies along with this challenge and to make it easier for them to complete the migration, my team at Vaadin has been building an automated refactoring tool that can perform a lot of these transformations going from Vaadin 8 to the latest Flow. Two tools that we considered to accomplish this are JDT and OpenRewrite. I would say at their core, both of these products are completely suitable. They give us the confidence that they would be able to, that we would be able to build a tool on top of them. And they fit the minimum requirements. So for me, minimum requirements for using a framework like JDT or OpenRewrite is that first of all, the library needs to be able to read the Java code, and it needs to be able to read it the same way that the compiler would read it. And secondly, the framework would have to make it possible to make changes to the application or to the code, but to do this in a very specific way and also in a way that would not cause side effects. So JDT and OpenRewrite do both of these. They fit this perfectly, but they do this in different ways. So JDT is built on top of the JDT core, which is at the bottom of, or at the foundation of the Eclipse product. And OpenRewrite is using the Java-C internals from Sun. So that's perfect. So there's millions of developers who are compiling their applications with Eclipse. There's also millions of developers who are not compiling their applications with Eclipse. If there's any aspect of the Java language specification that would be interpreted differently by Eclipse or by the Java-C reference, certainly many people would have discovered that by now. So we have a high confidence on the parser. We also have a high confidence on the way that manipulation can happen because both of these do this in a way that that limits the changes to specifically that place in the code where it needs to be applied. So with JDT, they do this with a combination of an abstract syntax tree and a document model, and JDT is providing the synchronization between these two models. And OpenRewrite is using something it calls the lossless semantic tree. Why is this so important? Well, a key area where we find that often reengineering tools or reengineering libraries fall short is that it's often very difficult to preserve comments and white space. So for us, it was actually important that we made as few changes as possible to the code. So we wanted to get, certainly not have white space and comments flying all around, and for the developers not to recognize the code. Okay, so for our specific application, we have about 1,000 different changes that we're making to the Vaadin applications in order to help them move from Vaadin 8 to Vaadin 24 now. That's the latest version. And they're pretty evenly distributed between types and invocations. So invocations is going to be anything like a method invocation or a class instance creation expression where we're creating a class new. Types are much more complicated, and you will find types in the application being used in different node types. I think that's the main challenge of types, is that there's so many different node types in which they can occur. So we can have types occurring in the code inside type declarations, so in an extends clause or in an implements clause. We can have this in cast expressions. We can have it in type arguments that we're sending to generics. We can have local variable declarations, and in this example, the formal parameter of this method declaration is actually counting as a local variable declaration. We also have the return types in method declarations, then annotations, and there's the list goes on. So this is not an exhaustive list. So the challenge then is to make sure that we're finding the types in all the different situations in which they can occur in the code. And I say it's pretty much 50-50 because, well, a type can have many methods that it's declaring, but a type there's only one type of the type, but it can occur in multiple node types inside the abstract syntax tree. All right, so this is a tools in action. So I'm going to show this in action. And to do that, I have a little sample prepared. I've got a sample application, just a simple bare bones hello world that's going to suit our purpose, where we've got a student service, and a student service is going to invoke an old method in that's been defined in both a second class and a first class, but the first class is getting its definition of old method inherited from an old library. So we have an old library, A class, and the A class has an old method. And we have a different method in second class that is not related to the old library at all. And what we want to do is help this university migrate from old library to new library. And part of the new library is that instead of old method, it has a new method. All right, so I'm going to pause the slides now, and I'm going to do something very dangerous, which is to demo. See if I can do this. All right, so here we have Eclipse. So I've opened this in Eclipse, and what I have here, this is my visitor inside Eclipse that is going to do exactly what I just said that we wanted to do. So to take, to iterate over all of the method invocations that we find inside the code, we'll see if that method is indeed a method that's been declared inside the old library package. And if it is, then we're going to test to see if that method corresponds to the signature public void old method. And if it is, then we're going to set the identifier to new method. So I can demonstrate this by debugging it, actually. That's one of the, I guess, the pros of working with JDT and Eclipse is that it's easy to debug a plugin. Oops. One moment as I select the right one. Okay, so this is now going to start another instance of Eclipse. And this is tools in action. So we have some waiting in action. Right, so what we're doing here is, well, obviously we're starting a new instance of Eclipse that's starting in the foreground. And once that's started, then we'll be able to open our university project in a way that's completely not related to the environment in which we're developing our tool here. And then once that happens, because we've set a breakpoint here, we'll be able to start that as soon as the second Eclipse starts up. And we'll be able to debug through it and hit the breakpoint, and then we'll be able to see what's happening. Okay. It's now started. Here we go. Here is our university project. We've got our com.old library, and then we have our application here. And here is our student service class that has two methods. One is invoking the old method of first class, and we can see where it's been declared. If we hover over it with our mouse, we see it's in old library, and then this one in second class, we can see that this is just in second class. So I will launch the plugin. My first Eclipse is going to start flashing yellow because it wants to start debugging, and we can do that. Here we are inside our code, and we're able to debug. So let me just jump through a little bit. And we see we're retrieving the method binding, and then we're testing to see if it's null. Then we're getting the declaring class, and we see, yes, indeed, that method is declared in a com.old library. We can do the second test to see, is it old method? Yes, it is, and we can change it. All right, so we've done our first method invocation. We can now do our second. We know the second one is the one that's going to the second class. So let me jump and jump. And when we get here, we know that's going to fail because it was not declared in that class. So that's perfect. That is what we expected. So we can end the running there, and we can go back to our Eclipse, and we'll see it's changed to a new method. There we go. Okay, right. It's not the most amazing thing that you've ever seen, but yes, that is indeed how it works, and it's really cool that you can debug. Now that was the JDT part. Let's now look at the OpenRewrite part. We can have the same thing going on. And I will not use Eclipse for that. I'm going to use my IntelliJ that's open. And here's the exact same code, but then implemented in the way of OpenRewrite. You can see I was testing this before I came here, so let me just clear that so that you don't peek. All right, so I have the exact same classes. I've got my first class and my second class and my old library. And I have my recipe, my OpenRewrite recipe here, which is the rewrite method class. And here it's slightly different. We, instead of working with a resolver, what we're working with is a method matcher. And so shout out to the crew from OpenRewrite who helped me understand how this was working. But the method matcher, it doesn't say resolver, but it actually is doing resolving. So if you would run this, we would see that it would, just like in JDT, it would detect that where the old methods, the two different old methods where they had been declared. So once we've defined our method matcher, we can specify a pattern for the library or a pattern for the package, and we can specify a fragment of the signature of the method. And then we will visit, and then we will apply this this method here. We'll execute the method for method invocation, and then we'll see if the method matcher matches that method. Then we can change the name to new method, and it would happen like that. So yeah, we could debug this also, but I think it's straightforward to simply run this. And because we're not starting a whole new instance of IntelliJ, that's going to go much faster. And here's the output. So it is able to detect, it is able to do the resolving just like in JDT. They don't use the word resolving, but they call it matching. But we have the functionality that we're looking for. All right. So that was what I wanted to show and tell about both JDT and OpenRewrite. Let's go back to the presentation then, because we were saying earlier that we were looking at method invocations, but we were also looking at types. So types are also something that we need to change quite a lot. And if you remember from the transformation, basically what we were trying to accomplish here was to go from old library A class to new library A class. So wherever in the code that we would find A class being referenced, and that was to an old library, we would need to change that to new library. So the cause, let's say the start and the endpoint, the desired endpoint that we're looking for would be an import. So you could look at this and you can say, well, that's easy. We can just change the imports. And yes, technically that is supported by both JDT and OpenRewrite. There's a lot of problems that can occur if you start to try to change types by modifying import declarations. So instead, what we've done in order to handle the types that are occurring in the code is to take a different approach. We're going to take an approach that's in two phases. Our first phase would be to insert the fully qualified name of the class to which we are migrating or to which we're transforming. And then in a second phase or a second step, we would go through the code and simplify the fully qualified names and adjust the imports as necessary. There is a drawback of this, of course, because once you take this approach, you're going to have to do that for every different node type that you have in your code that is related to a type. So you would need to remember that it could occur in a cast expression. It could occur in a catch expression, in a try statement. It could occur in a type argument or in an extends clause. It could occur in all of these, and you would have to set up your methods to handle all of them. Now, both JDT and OpenRewrite do give you some shortcuts so that you can sort of like blanket change types. There's ways of making this very simple. But if you need control over this, so there could be situations in which one type in one of the types that you're transforming in one of the node types, it would be treated in a different way. For example, if you have a interface and you're replacing the interface with another type that is not an interface, for example, an abstract class. So if you have in the class from which you're migrating, this would be implements old class or implements old interface, and you wouldn't have a new interface to change it to, but this would be an abstract class, then yeah, you would need to find some other solution at that point. But once again, so JDT and OpenRewrite, they're both equivalent. I've got methods for all of these. So the names might change. So instead of cast expression, you might have type cast, or try statement, you might have try.catch. But it's possible to visit all these different node types using both of these tools. So just comparing them for the suitability of changing invocations and changing types, I think JDT and OpenRewrite, they're fully suitable. I think they both have some sharp edges here and there. JDT, I think it's easier in JDT to, for example, find the jar. So actually find that jar in which the resolver is finding the declaring class. I think it's easier in JDT to actually get that information, and sometimes this information can be useful because developers sometimes like to write their own code in the same package as the package that they're using so that they can get access to protected members. They do that, but yeah, that's one way of being able to determine where that is coming from, is to get the source. On the other hand, JDT has some things that are difficult, like, or might surprise you, because they have a number of visitors that you really have to understand what these visitors are doing, because sometimes, one example was we had a method invocation, and JDT has a visitor for method invocation, but it also has a different visitor for a super method invocation. So it makes that distinction. So if you go quickly and you say, oh, I'll take the visitor for method invocation, and you're not realizing that you're not catching any of the super method declarations, or that this distinction exists, then you could be missing some important changes. All right. I think there's pluses and minuses for both of these. Where I see JDT and OpenRewrite really hugely different, that is that OpenRewrite clearly is much better for newbies, or for people who don't have, or for teams especially that don't have a lot of experience. We're either working together on these kinds of projects where you're doing language reengineering, and there's a number of ways in which it does that. So I see OpenRewrite as being a very safe, or as providing a very safe sandbox for tools engineers, and there's a number of things that are built into OpenRewrite that help you simply avoid certain awkward or confusing conversations, like the way, well, first of all, the way that you would identify and organize your recipes. So OpenRewrite has it built in to its library that the recipe class has a number of members that are actually there specifically to help you keep track of potentially large number of recipes that you might need to write, like giving recipes an identifier. So first of all, understanding that you might want to identify these and do this in a friendly way. Another thing is including a description with a recipe, but you can also include a test with a recipe. Sometimes a test of a recipe is the best documentation that you can have, where you can say, okay, considering this input of code, we want this as output of code, and that is what this recipe does. And that can make things very clearer, especially if the logic is quite complicated and you need to write a lot of things in Java. The second point that I would raise would be the way that you would architect the recipes. So OpenRewrite has a very, let's say, it's a very easy and a very obvious way, if you're using OpenRewrite, to write your recipes so that they could be configured declaratively, so that you can use these in your pom.xml, and you can set options, and you can actually change the behavior of your recipes from outside the recipes. So thinking about making a distinction between what is happening in Java procedurally versus what is happening in your pom.xml in a more declarative way. That helps give you also a separation between the tools engineers, the people who are creating the tools, and then the people who are actually using the tools, perhaps to do work for customers or for specific users. We already talked about how to test your recipes. And I've mentioned these three things here because, yeah, you could achieve the same thing in JDT, but you would all need to agree on it. You would need to have a conversation with your developers and figure out, okay, how are we going to do this? How are we going to identify all of our rules or our recipes? How will we document them? How will we test them? And how will we work with our consultants who are using the technology and make that configurable for them? Another thing, of course, is the marketplace. So OpenRewrite has a marketplace. I have not found a marketplace for JDT recipes or anything similar. So there's a lot of things that have been used before that you can start using just out of the box without having to reinvent all these wheels. And then finally, there's this consistent reliance on Maven or Gradle. So OpenRewrite is compatible with both of these. And JDT would be as well, but with JDT, it's a little confusing, or it can be very confusing when you're creating a plugin and you're not really sure at what point you're using, or you're not sure at what point that you're tying yourself into Eclipse, the IDE. So there's JDT, which is part of the Eclipse project, and you can create a JDT application that doesn't use Eclipse at all and is based on Maven, but making sure you're making the right choices of which libraries you're using, that can be a bit tricky. All right, and then the last point that I wanted to add was performance. So especially for large applications, performance is really key. It's a deciding factor in how you're creating these tools. The benefit of this is going to be enabling iterative development. So we've heard a lot of about, from agile development, we've heard a lot about incremental and iterative development at the same time. But using these kinds of tools, it really does enable a purely iterative development so that you can create a recipe, you can test the recipe and see if it's good. If it's not good, you can throw it out and you can try it again. You can try it again and again. And when the logic starts to become complicated, and especially when the number of APIs that you're changing, this becomes extensive, then having this performance is actually really important for your development because you need to test and verify and it's good to test and verify quickly. So I can say we are using JDT. We are going to use OpenRewrite also for certain things that have already been solved. It doesn't make any sense for us to, like I say, reinvent the wheel if certain very specific refactorings have already been solved in OpenRewrite. But the core of what we're doing is all done in JDT. And performance really is one of the key factors for why we made the decision. And I can say just as in terms of benchmarks, we have an application that we converted or that we transformed that had 150,000 lines of code. And we applied our tool built on top of JDT on that was applying about 1,000 changes, or 1,000 rules that was applying 1,000 changes, and this was done in 16 minutes. So that is really quick. I mean, if you can test something 16 minutes later, you can have the results on from the application, and the proof is in the pudding, of course. Then that is that's going to help you move forward. All right, that's what I wanted to share with you. Thank you very much. I think we're out of time.